This is the Carvera Air from Makera, a desktop CNC machine capable of milling even metal. This machine is outstanding for many reasons. It offers an affordable and easy entry point for learning CNC machining, or serves as an extremely useful tool in your workshop to take your projects to a whole new level. Even if a desktop CNC sounds like a toy or something just for fun, that's definitely not the case here. The Carvera Air is seriously capable machine. It includes quick tool changing, fourth axis, laser engraver, air cooling, a dust management system, a huge selection of tool and end mills, a professional CNC controller, and even their own CAM software, which comes free with the machine. And all of this is available for around $2,000 to $3,000. Also the community. Especially I wanna highlight the Makera own YouTube channel, where you can learn everything about the machine or the software. This channel was huge help for me. Everything might sound a bit too good to be true, but it is what it sounds. Let me show you my first month and a half with Makera Carvera Air. And if you are willing to stay with me for about 22 minutes, I will show you excellent results, limit testing, broken tools, machine crashes, tons of cleanup, and even more impressive results. So to start the journey, let's go back 1.5 months. The first example project I'm going to do with the Carvera Air is Pirate Ship. I start with this because this is by far the easiest. For this we need two tools, 25x3.176mm single fluid flat end mill and 0.2mm 30-degree V-bit. The ship will be engraved into a epoxy block that comes with the printer, with CNC. I secured this to the build plate exactly as it is in the manual. Then I selected the right file in Carvera controller that I am controlling with my Samsung tablet through Wi-Fi. To start this, we need to select scan margin and auto C probe. Because this is nice and flat surface, auto leveling is not needed. And let's go. First the machine asks to install the probe. Now it zeroes the Z-axis and it shows where the work will happen. And when this is done, machine asks us to use tool number 1, which is the 25x3.176mm single fluid end mill. When this is done, the machine starts the work. The first step is roughing. This removes major amount of the material. After this step, we wouldn't see any nice details yet, but the model should take some shape in low resolution. I also left the dust shoe on because the roughing process makes so much chips. If we won't clear them, we are not available to see anyway what is going on. Even though this is not really easy to suck them because they have some static charge. They love to stick everywhere. But now when this step is done, I nicely vacuumed all the mess away and we can see the result. So far everything looks good and we can continue. Next I used engraving bit and continued with the job. After this step we should see Pirate Ship engraved on it. When this is done, we have to go back to the previous tool and cut this out. Indeed, this looks absolutely perfect. The level of small details are mind-blowing. Even some cheaper resin printers cannot deliver so good result. This project was great success. Now I'm going to create another example file, and this is PCB. I have never done PCB by myself, so it's really nice opportunity to learn something new. This PCB is actually one part of the bigger project, the LED lamp, that you can do with the Carvera Air. All the materials, tools and files comes with the CNC. But I don't finish the whole project because in every review video everybody doing the same thing all over again. Instead I'm going to do my own stuff and going to cut some metal, but about this a bit later. So after I attached the one-sided PCB board to the machine, I search out all necessary bits. We need 0.2mm 30-degree V-bit, 0.8mm corn bit and soldering mask removal tool. You can do this project without soldering mask, but I decided to use this one also. This means I have to select the file with soldering mask. It starts pretty much the same way as it did before, but this time we also select auto leveling. When the probe has done its job, you install the first tool and click confirm, or the button at the top. I don't know much about electronics and PCBs, and I'm not completely sure what I'm doing right now, but it's going great. When this is done, I applied green soldering mask. It took around 15 minutes to fully cure this soldering mask with a UV lamp. Now we have to select new job in Carvera controller, and we can continue with our PCB. First we need to use the mask removal tool. And this happened. So I crashed the machine. This was my mistake. To be sure, I don't even know exactly what I did to cause this, but somehow I messed up the C value. Anyway, I fixed this by using the probe, and this time everything seems to be completely fine, and the job started without any problems this time. About this previous crash, one thing was really nice to see. When this happened, the machine instantly understood that something was wrong and stopped. Because this, my PCB, tool or machine didn't got damaged. This is really securing to know that the machine is smarter than me and I need to work way harder to break it. So yeah. Anyway, this is also done now and we can continue with the next and final step, 0.8mm corn bit. This one will bore the holes and cut it out. This is really nice, my first PCB. I probably finish this PCB later, but not in the video, because I don't want to turn this to complete comedy. But as much I can tell, everything turned out like it should. And here is the crash site, by the way. Only scratched the soldering mask a little. Now moving on to aluminium. Before I'm going to cut some actual thing, I first want to run a test. I'm going to cut 8 different pockets with different step downs. First we start with a standard 0.2mm step down, but for every pocket we add extra 0.1mm. So progressively we move from 0.2mm to 0.9mm. But when we reach to 0.6mm, aka the fifth pocket, we decrease the feed rate from 500mm per minute to 200. With this test we measure few things. First, can it even make to 0.9mm? Then I also measure the time how long it took to cut every bucket. And at the end, we check the quality by visual inspection. Also what has to be mentioned, what type of aluminium we are cutting. It's 6082 T6. It's stronger than the most common 6060 or 6061 aluminium. So keep in mind, even though we are milling aluminium, but aluminiums are also different though. So, right now we are cutting into slightly stronger aluminium. I almost forget, the air assist is also on. The compressed air is coming from the silent compressor that I specially bought for this machine. The test went really well, and by visual, I cannot say any difference between the cuts. But if you look how long it took to mill every pocket, the difference is clear. Obviously, increasing the step down lowers the job time. We only see big jump up at 0.6mm step down. This happened because I lowered the feed rate. Now I know I did it a bit too aggressively. There is one thing more that changed over the different step downs. The chips. At 0.2mm, we didn't create chips. Instead, fine aluminium dust. This is not ideal. When we reached around 0.6mm, we started getting nice aluminium chips. This makes the cleaning way easier. Even though this test didn't hit the true limits of the machine, the information is really valuable to choose optimal settings for the next operation. I'm going to cut this model. This looks like some type of lead in real life application. Even though this is just a test piece, I will not use it anywhere. So to get started in Carvera CAM, first I graded 3D pocket tool paths. First I face off majority of the material. Then I use 3D pocket tool bath for most of the pockets and holes. Then I'm going to cut M4 threads to the 5 holes at the sides, followed by chamfer. And finally, I'm using contouring to cut this all out. Because I ran the aluminium test before, I'm using 0.9mm step down for majority of the operations. Threading and chamfer settings I didn't change, they are standard. But the last operation when I got the part out, I am going even more aggressive. I am using 1mm step down. It took me 1 hour and 50 minutes to cut this out completely. The first operation had a lot of air cutting for some reason that I didn't figure out. This added insane amount of time. But the part itself, perfect by visual inspection. Also the thread works nicely. About the accuracy, well, it seems to be spot on. The little extrusion should be 4mm thick. And they are. I got readings between 3.99 to 4mm, which is perfect result. The circle at the middle should house 608cc bearing, and it seems to do it, but the press fit is too loose. I added an extra 0.2mm clearance, and this was too much, because the machine is accurate. The lower number like 0.1 or even 0.05mm should do the job perfectly. Just saying, if I 3D print this hole, I add 0.3mm clearance and it's still a press fit. Before we jump into 4th axis, I also tested the laser. Basically the laser goes to the machine like any other tool. Then connect the small tube to the air nozzle, optional but recommended. And last, connect the wire. And we just transferred CNC machine to laser engraver. I engraved example file, but about the laser I have to say, good but slow. It's really nice to have option to use laser engraver when needed. The result of the example file is perfect, absolutely beautiful. Moving on to probably most interesting feature, or let's say add-on, the 4th axis. This doesn't come with the machine, you have to pay a little extra to get this. But I can say it's worth because it works so well and it's extremely cool. For my first project with 4th axis, I designed something like this. It's a shaft where in the middle is a gear. Usually I use some steel rod as a shaft and then I connect the 3D printed gear with a coupler or with a press fit to the shaft. It will be insane when I can start producing something like this out of metal. It would take my project to completely next level. So first in Carvera Cam I made my program. Well, here I need to criticize the software a little. For 3-axis jobs Carvera Cam is all you need. But with 4th axis you can do just basic things. thing to be exact, you have only one tool bed option, rotation relief. And that's all. For now I can do my things here, but in future I will not use Carvera cam for 4th axis. You have minimal control over your tool bed. The best 4th axis cam is Fusion 360, in my opinion of course. You have to use paid version for this, but it's worth, in my opinion of course. But anyway, I broke my first tool doing the job. This was my fault because I was too aggressive with the step down and feed rate. This is just part of the learning. But I still wanted to get my gear done. So this time I made the shaft shorter to save 80% of the machining time, and I lowered the step down from 0.9mm to 0.5mm. And this time I succeeded and gear turned out nice. By the way, the surface looks kinda rough because I didn't run the finishing pass because I didn't have the right tool for that, aka Pal N-mill for metal. I do have for wood, but I don't have for metal. It's good enough for testing the machine and it's nicely engaged with the previous half-ton gear. So for now I have used Makera Carvera Air for 1.5 months, and is it worth somewhat $2.5K? Well, the answer is really simple. Absolutely it is. Machine so small but so capable, plus free cam software that is excellent for 3-axis job and can use for simple 4-axis jobs. This is dream deal, by the way. It have never been so simple and affordable to get into CNC world or having this type of tool in your workshop. This is insane, to be honest. For me it unlocks so much doors while doing my project. And the biggest door that is wide open now is the metal door. So yeah, this machine will get so much use in my channel and you will see it really soon again. If you are looking machine like this, small but capable 4-axis CNC and little bit laser engraver, Makera Air is the answer for you. You don't find better deal in this price range. I hope I give you a decent overview of the machine, but trust me, I didn't hit the limits of the machine. Thank you for watching and see you guys in the next video. Bye.